What's going on, everybody? Mr. Diamond, and we're going to get into section 3 of our notes here. Now, this is going to be a decently long section. It's going to include working out some examples as well on paper. I apologize for my sneeze there. So what we're going to need to do first, though, is get on my pointer because that's very important. But we're going to have a quick summary here of the parts of the atom. So we've got protons, neutrons, and electrons that we talked about. Protons have a charge of +1, neutrons have a no charge, electrons have a charge of -1. For our purposes, protons have a mass of approximately 1 AMU, and neutrons have a mass of approximately 1 AMU as well. Neutrons are slightly heavier. That's because neutrons are made out of a proton and electron that have smushed together. Electrons are also super duper duper tiny. They're like 1/6728, or I don't know, some number that I don't think it's that number. Don't quote me. I'm not that exact, but it's a pretty small number. So we just consider it as 0 AMUs. Protons and neutrons are found in the nucleus. Because of that, they are called nucleons. It just means they're found in the nucleus. Electrons are found in orbitals rotating around the outside of the atom. And then what we're going to talk about here is that protons determine what type of element you have, neutrons determine what type of isotope you have, and electrons determine what type of ion you have. So don't worry, we'll go into more detail about what each of those means in a second. So knowing some parts of an atom actually lets you begin to predict what other parts of the atom will be. The biggest application is in what we're going to do here called isotope tables. I want to preface this with one very important thing. Isotope tables are not super practical for day-to-day chemistry or day-to-day life. I guess I'm sure that one's not a shock for some of you. But in actual chemistry, most of the time you will not be sitting down and working on an isotope table. This is stuff that you should eventually be good enough at to just mentally do and mentally figure out by just looking at the information that you have. We're doing the tables as practice, so just keep that in mind as we go through this. Two definitions we need to get through, though, are isotopes and ions. Isotopes are atoms of the same element that have a different number of neutrons. Technically, it's that they have a different mass, but they need to still be the same element. So two pieces of carbon, for example, one could be carbon-12 and one could be carbon-14. Those differ by mass, but they still have the same number of protons. They would still have to have 6 protons. Ions are any atoms that have charge, which means they have gained or lost electrons. The reason that they cannot have a gain or loss of protons is because that would actually change what type of element you are dealing with. So ions can only be formed by changing the electrons. Changing the protons will change the charge, but it'll also turn it into some completely different element, and that's not really what we're looking for here. To describe a specific single atom or a type of atom, we will use isotope notation. Isotope notation is represented by drawing the symbol, so that's X right here. Then you take the atomic number represented by a Z here, and that goes here on the bottom. And then you're going to have your mass number, which is equal to your number of protons plus your number of neutrons. If you remember back on this slide, we said those are the two things that have mass, so you're basically adding up how many AMUs that specific atom has. Very important key point here. This is the part where you're going to want to use your periodic table, but do not look on the periodic table for this mass number. That is the biggest mistake that people make when they get here. When you're doing isotope notation or when you're filling out an isotope table, we are not thinking about the element as it exists in nature. We're thinking about one very specific atom, and that specific atom may have more or less neutrons than it is normally going to have in nature. So you have to look at what the question tells you is the mass, or what the question tells you is the neutrons, and add that to the number of protons. So make sure you do not forget that. It is, again, it's a really common pitfall that people make whenever they're doing these. So notice electrons are not mentioned, and that's because unless an atom is also an ion, you're just going to assume that it has the same amount of electrons as it does protons. If it for some reason has a negative charge, you just add that many electrons. So -1 would be add an extra electron, -2 would be add 2 extra electrons. If it has a positive charge, you subtract that many electrons. So if it had a +3, you'll subtract 3 electrons. If it's a +1, you'll subtract 1 electron. I know that's weird, that to go negative you add and to go positive you subtract, but remember electrons are negative. So if you want negatives, you have to add something that's negative. And if you want positives, you have to subtract something that's negative. So remember electrons are negative. that will make it make a little more sense for you, hopefully. So we're going to go with a question that's not really in the form of an isotope table, and this is how it would be worded normally. An unknown substance has 27 electrons and a total atomic mass of 58 AMUs. Determine all of this atom's properties, including amount of particles and name. I don't know if you just heard my cat come running down the stairs. I apologize if you did. So we're going to go ahead, and from this, we're going to switch over to my hand cam. Man, my cats are having a party over there. So we're going to switch to my hand cam. We're going to try to get it lined up here. So an unknown substance. It has 27 electrons. The symbol for that is an E-, and a mass of 58 AMUs. So the missing information we have here is... we need to know neutrons, protons. We have the mass, we have the number of electrons. I want total particles. And then I want name. And I didn't put it in the question before, but I also want symbol. So let's go ahead and figure this out. First of all, does it in the question anywhere mention that it is negative or positive? An unknown substance has 27 electrons, a total atomic mass of 58 AMU. Determine all of this atom's properties, including amount of particles. It does not, no mention of charge. And if that's the case, electrons equals protons. So 27 electrons means we have 27 protons. We know that our mass number is equal to our protons plus our neutrons. So 58 minus 27 gives us 31. So we got 31 neutrons. And again, that's because, if you're wondering where this came from, this is 58 minus 27. Gives you 31. Total particles, 27 plus 27 plus 31. That's 54 plus 31 is 85 total particles. And now we need to know the name. So to figure out the name, this is where you're going to need your periodic table. So if I go ahead and I got it on my computer here, I'm about to pull up. And I've mentioned this before, you can just Google periodic table if you don't have yours close by. I'm at home and I forgot to bring one, so I don't have one around here. We're just going to look for whatever thing has this many protons. The number of protons is equal to the number you find on the table. So number 27 is cobalt. It's represented by a CO. Now, we need to specify, though, this is not just any cobalt. This is not cobalt in general. This is specific cobalt. And because it is specific cobalt, we need to identify it. Now, identifying by number of protons, that we already did. We said it's cobalt. Identifying by number of electrons, it's not super helpful. It's the same as the number of protons. What we're actually going to use is the mass. The reason we're not going to use the neutrons is because the mass is actually, you don't need to use number of neutrons in any calculations if you're trying to figure out like how heavy something is or how it differentiates. The neutrons are really only there for stability purposes, so 58 will tell us based on number of protons how many neutrons it has anyway. You just need a little bit of math. So we'll call that cobalt 58. And then we want to do symbol. Cobalt symbol is CO. We're going to put the mass up there, and we're going to put the number, atomic number down there. 2758 cobalt. So there's all the information. Now, if we go back to the screen here, usually what I'm going to do for you is I'm going to give it to you as a table like this. And if you've got a table like this, you can do things like, okay, 84 electrons must be equal to the number of protons because it doesn't mention charge, so that's 84 there. 84 would then also be the atomic number because protons is equal to the atomic number. 84 and 126 combine together to give me my mass, so add those together to get my mass, and then from there you can look up what 84 is on the periodic table to determine the name and the symbol. I know I kind of rushed through that, but I just gave an example of what that would look like. It would be worked out the same way. This is just how they'll actually look in this class. It'll be a lot more neat and a lot more organized than that. Now, I think we're going to cut off there. just so that way I can do the other example as a separate video and kind of break it up a little bit for you guys. I hope that makes sense. If not, please shoot me an email, try to hop into one of the Zoom calls, or whatever works for you to be able to get help. I guess you can send me a messenger pigeon or something like that if you think that'll get my attention. But I hope you have a great day. I hope you have a good evening, and I hope to see or hear from you soon.